15-16, and I'll take a look at 1515, which is quite similar. A couple differences, but it actually gives us some data. It's kind of simple data, but it seems kind of obvious when I look at mine. I think that the example on the top of page 548 does a better job of explaining kind of what you're looking for, other than just having this kind of raw data. But if we take a look at it, it does say this. It says the null hypothesis and the alternate hypothesis are that the frequencies are equal or that they're not equal. In spite of the equal and not equal, these are always one-tailed tests. Okay, so when we use our significance, we're still just looking at it as one tail. We don't do any division or anything. We go ahead and use the significance level that's been provided for us. And so it asks, it says state the decision rule using the 0.05 significance level. Okay, and then we have to compute the value of chi-squared, and then we have to give our decision. Okay, so first we got to look up what our critical value is, and chi-square, there's a separate table for that. It's on page 738, I believe. Okay, well, that's what it was on the one before, but in this case we have 3, and they're called categories, right? So k is equal to 3, so k minus 1, our degree of freedom is 2. Okay, and our significance level is 0.05 given to us. So I found a table, and we got it's not perfect, but it's should work. Degrees of freedom 2 and 0.05 is our significance level. Okay, and so 5.991 is our critical value, right? So I'm going to reject chi-squared or x squared if my value is greater than 10. So how do I calculate that value? Well, the formula is one of those nice looking oddball formulas. It's right there on page 545, kind of in the peach colored rectangle there. It says chi-square test statistic, which is chi-squared is equal to the sum of, and then in parentheses, f sub 0 minus f sub e squared divided by f sub e. So another way to set that up is to say this, that okay, here's our f sub 0, okay, and we've got to subtract that from f sub e. F sub e is simply our average, okay, of these, of what we have. Okay, so we've got 10, 20, and 30, and I can just do an average in my head. You can tell that that's 20. Okay, and then you could do this a couple different ways. I kind of set it up like they did in the book, I believe, on about page, towards the bottom of page 546. So I went ahead and put this in here. You could have also said that this is equal to this minus this, you know, like we've done with finding variances and standard deviations. This is similar, but there's a little quirk here at the end, so we can't just do it that way. But I put the 20 in, okay, in each of those, and then it says it's f sub 0 minus f sub e, because this column becomes f, and then I don't know how small I can get here. Maybe. I'll put in a little e. Ooh, that's pretty close right there, isn't it? Dang, it's all right. Okay, so that's my f sub e. So I subtract one from the other, and I get a minus 10, 0, obviously, and a 10. And then I square that, okay, just like we have so many times. You know, it's equal to this to the second power. And I carry that down. And then I have to divide this by my f sub e again. You know, and you could use either one, I guess. If you want to keep this, if you got it set up like this, then you can simply say this is equal to this one divided by this one. And once again, you can carry that down then, if you do it that way. And then it's the sum of that. If you go back to that formula, that kind of big E looking thing there in front of the parentheses means the sum of. Probably looks a lot like this, where it says auto sum, right? Okay, and so you sum those and you get 10. There's your calculated statistic, or it says for B it says compute the value of chi-squared. So there you have it. Okay, it's 10. Now, is 10 greater than 5.991? It always has been, in my experience, considerable experience. And so, yes, it is greater than, so I'm going to reject, and I'm going to come to the conclusion then that I reject the null and accept the alternate hypothesis. Then I come to the conclusion that there is a considerable difference between these samples that I have. So there's a 15-16.